For section 2, I'm going to talk about how we can multiply and divide rational expressions. So something that is rational means that it's like a fraction, or it can be represented as a fraction. So there's times in the past where you would have a decimal answer, but you could represent it as a fraction, like 0.5 represents a half, 0.75 represents 3/4, those kind of things. So we're going to be looking at rational expressions in this section and in the coming sections here. And we're going to first focus on how we can multiply and divide these rational expressions. So here's some examples of what a rational expression would look like involving these polynomials that we've been dealing with the last couple of chapters now. So we have like 3x to the 7th all over 2 minus x. This one says x squared minus 2x minus 3 all over x squared plus 5x plus 4. And another one is x to the 4th minus 4 over x plus 2. In order for us to simplify rational expressions, we can do that by factoring either the top, the bottom, or both. And then if they have common factors, we can actually cross those things out. So let's take a look at some examples here. This first one says x squared minus 4 over x plus 2. So this is a difference of squares on the top. And so what we can do is factor this so that it says x minus 2 and x plus 2. Because that's how the top would factor. Anytime you do a difference of squares, you have two parentheses. They each are going to get an x. For this one, the square root of 4 is a 2. And you have to have one positive, one negative. That way, if I FOILed it, my middle terms would cancel each other out because they would have opposite signs. Now, this is still all over x plus 2. And so these two, x plus 2, one on the top, one on the bottom, they're the same, so you can basically cancel them out. Just like if you had a number like 5 over 5 or 10 over 10, something like that, if you reduce them, it just becomes a 1. So you can go ahead and just kind of cross those off. This is simplifying that expression. And we're left with just the x minus 2 quantity. And that would be our answer. Okay, why don't you try this one? Try to factor it. And when you're ready to see the solution, I would pause the video for you to try it and then start it back up when you're ready to see the solution to this problem. So for both the top and the bottom, when you're trying to factor these, if you think about what we did in chapter 2 when we were factoring quadratic expressions, when there's just a 1 sitting in front of those x squareds, you want two numbers, in this case, that multiply to a negative 3, and you want them to add to a negative 2. And on the bottom, you want two numbers that multiply to that 4 and add to a 5. So on top and on bottom, you're going to have two sets of parentheses, and they each get x's in them. Now on the top for factoring, we're going to have x minus 3 and then x plus 1, because negative 3 and positive 1 would multiply to a negative 3 and would add to a negative 2. And then on the bottom, your two numbers that multiply to 4, add to 5, would be 4 and 1. So you'd have x plus 4, x plus 1. Now I see that I have x plus 1 on both the top and the bottom, so those can cancel. And I'm left with x minus 3 over x plus 4. Now, to kind of continue on with what we've been talking about, a rational expression is not defined if the denominator ends up equaling 0. That basically reminds us that we cannot divide by 0 mathematically. If we try to do it, you're going to get an error message or your calculator will say undefined. It won't do it for you if you're trying to divide something by 0. So when we're dealing with these rational expressions, we have to make sure that we're stating if there are any values that cause problems for the fraction. If I put in a certain number and it causes me to get a 0 in the denominator, then I want to make sure that I state that x cannot equal that specific number. For example, if I have a problem that looks like this one. 3x squared y to the 5th all over 15x y to the 7th. I can reduce my 3 and 15 so that it becomes 1 over 5 because I can take a 3 out of both. Now with my letters, with those exponents you subtract when you're dividing. So you're going to take x squared minus x, which would just be an x. And for my y's, when I do 5 minus 7, I get negative 2. So I have y to the negative 2. Now I can't leave a negative exponent, so I need to actually take just the y term and drop it to the bottom. So it says x, or 1x, on the top now, and on the bottom you have 5 and a y squared. Well, in order for this to not become a 0, so I'm kind of thinking about what values would make this whole fraction cancel out and become a 0, I need to state what values don't work. So x cannot equal 0, because if I have a 0 on the top, 0 divided by anything is going to be 0. I don't really want that to happen. And for y, I also don't want y to be equal to 0, because if it was, 0 squared is 0 times 5 would still be 0. And then I'm trying to divide by 0, which I said earlier we can't do. So this is what those excluded values would be, and that's what they mean for a problem like that. Let's look at another one. So we're kind of going back to our factoring problems here. So I'm going to, on the top, take out what they have in common, which is just an x. So I have x pulled out front, and then I'm left with 2 minus x on the inside. On the bottom, if I go to factor this one, I need two numbers that multiply to negative 2 and add to a negative 1. And so that's going to be negative 2 and positive 1. Now I am going to do a little bit of manipulating here. I would really like to get this 2 minus x to switch so that it's x first and then the 2. So if I do that, I have x times a negative x plus 2 all over still that x minus 2, x plus 1. Now that negative x plus 2 is really similar to x minus 2. What I'm going to do now is actually take this negative and pull it out front. And so that x that I pulled out front is now going to say negative x. And when I take the negative out from the x, I also have to imagine that there's this negative sitting in front of the 2 as well and take that out. So I think about dividing both of those terms by negative 1. And so it would become x minus 2. So it's going to switch the signs of both of them. Now, the reason why I would want to do that is so that I can get the x minus 2's to reduce, to cancel each other out, like so. And then I'm left with negative x over x plus 1. Now let's talk about any numbers that would cause issues. So if I think about on the bottom here, focusing on when I factored it originally, if you can think to yourself for a minute, what numbers, if I put them in for x, are going to cause me to get a 0? Well, for that first one where it says x minus 2, if I put in a 2, 2 minus 2 would be 0. And then it's 0 times anything, so it's just going to give us a big 0 on the bottom, and that's a problem. So I don't want x to equal 2. The other value I don't want x to equal would be a negative 1, because negative 1 plus 1 would cause that to become a 0 as well. Any other number should be okay. And you could think, like, if I put in a 0, if I put in a 1, if I put in a 3, or even some negative numbers like negative 2, negative 3, those should all not cause problems. And so I should be able to say that those are the only two excluded values. Okay, go ahead and pause the video and give this one a try, and then resume the video when you're ready for me to go over it. So what I did for this one is on the bottom, I just factored out the 5, and that left me with p minus 5, which is the same as the top, so those cancel each other out. Now, there's not a 0 on top. Remember that these basically became 1s, so my answer is 1/5, okay? But p cannot equal 5, because if I put 5 in, I'm going to get a 0 in the denominator, and that would cause it to cancel. So I want to make sure that I don't have a 5. Okay, let's start this one together, and then I'll let you continue to finish it. So this one here on the top, before you even try to factor that, because that would require you to factor it the long way, I am going to encourage you to see if there's anything that you can take out of the top, anything that they all have in common. So they all could be taken out with a 3, like all of those numbers are divisible by 3, and they all have at least one x, so I can take out an x from everything too. Now if I do that, I'm left with x squared minus 2x minus 8. And then this is still over x squared minus 3x minus 10. So pause the video here and try to finish this problem on your own, and also make sure that you're stating any values that need to be excluded, and when you're ready for the solution, resume. So on the top, how I factored it, I needed two numbers that multiplied to a -8 and added to a -2. That would be a -4 and a +2. On the bottom, I need two numbers that multiply to a -10 and add to a -3. That would be a -5 and a +2. So my x plus 2's cancel each other out, and I'm going to be left with 3x times x minus 4 on the top. I'm not going to worry about distributing that 3x back in. I'm just going to leave it factored. And then on the bottom, I have x minus 5. Now, coming back to this original denominator here, that's where you want to look to find those excluded values. And so for this one, x cannot equal +5, and it cannot equal -2.